Example 10, Kriging Interpolation. In this example, we will perform Kriging Interpolation on spatial data to predict values at unsampled locations based on sampled data. First, we need to load our data from CSV file. This data includes coordinates and corresponding values. We read the CSV file and extract the columns for X longitude, Y latitude, and rainfall amount. Next, we set up and perform Kriging interpolation using the ordinary Kriging class. Finally, we visualize the original data points and the interpolated surface. In summary, we loaded the data from CSV file and extracted relevant columns. Then we used Kriging interpolation to estimate values on a grid. Finally, we visualized both the original data and the interpolated results. This figure is original data points. And this one is output of Kriging interpolation rain. Example 11, time series geospatial data. In this example, we will visualize and analyze time series geospatial data from NDWI, normalize different water index images. We processed these images in Google Earth Engine platform. Firstly, we will start by loading the NDWI raster files for each year and convert them into a 3D NumPy array. Then we will visualize NDWI data for each year and save the plots. After that, we will identify water bodies using a threshold, calculate the lake area, and visualize the results. And we will analyze changes in the lake area over time and plot the trend. In summary, we loaded NDWI images from multiple years and stacked them into a 3D array. Then we plotted NDWI values and water masks for each year. After that, calculated and analyzed lake area changes over time and visualized the trend and performed statistical analysis. NDWI for 2014, NDWI for year 2015, 16, 17, and 18. In the left side, we have NDWI for each year, and in the right side, we have water masked year for each year. This timeline represents change in lake area of Dukan over time, and statistical analysis display the slope of 18,504 pixels per year increased. The blue line represents values of pixel per year, and the red line represents trend line. Example 12, digital elevation model DEAM visualization. In this example, we will visualize a DEAM of Erbil Governorate and analyze its gradient using rasterio and matplotlib. We will start by loading the dim file and visualize it using matplotlib. Then we will calculate the gradient of the dim in the x and y directions to analyze the train's slope. The output is figure of digital elevation model of urban governorate. Example 13, terrain slope calculation. In this example, we will calculate the slope of the terrain using the dim and visualize the results. The slope is derived from the gradient of dim. Firstly, we open the dim file and read the elevation data, then handle no data values by creating a mask. Then calculate gradient using npy.gradient function. Then we calculated the slope using this equation. We applied the mask to the slope to handle no data values properly. Finally, we plotted the calculated slope using matplotlib with a terrain color map to represent different slope angles. The output figure displays slope of Erbil governorate in different colors. Example 14, terrain aspect calculation. This example demonstrates how to calculate the aspect of a terrain using dim data. You will need to load your dim data, which is typically in the form of a 2-day array. For this example, you will assume dim is your 2D NumPy array representing the dim data. Then calculate the gradient in the x and y directions using NumPy. Then calculate the aspect in degrees and adjust the values to be in the range of 0 and 360. After that, use matplotlib to plot the aspect. The figure display aspect of Erbil governorate using dim data.